All right, welcome to Next Gen Manufacturing Nexus. Today, we're going to talk about something wild, the quest for the perfect part. And I don't just mean good enough manufacturing, no. We're talking about absolute flawless perfection. And you know, the ultimate stress test for this kind of thing? It's got to be the aerospace industry, where the standards are, well, literally astronomical.
Think about it. In aerospace, a part isn't just a cog in a machine. It's the thing that stands between a successful mission and a catastrophic failure. We're talking about everything from a rocket nozzle down to a single tiny bolt on a landing gear. Every single piece has to be perfect. There is absolutely zero room for error.
So, that's the big question, right? That's what we're going to dig into. When the stakes are that high, how do you even start to build a process that can promise perfection? Not just once, but every single time. Okay, to make this real, just look at this number. Plus or minus 2/10,000ths of an inch. That's a pretty standard tolerance for a critical engine part. To put that in perspective, that is way, way finer than a human hair. If you're off by even that tiny amount, you could compromise the whole system. So seriously, how is this even possible? All right, let's break it all down.
It all starts with what they call the zero failure mission. And look, this isn't just some catchy slogan you put on a poster. It's a fundamental mindset. It forces you to completely reinvent how you think about manufacturing from the ground up.
So how do you actually pull off a mission like that? Well, the answer is in a totally new digital blueprint for how we make things. The factories that are winning right now, they're the ones that treat every single cycle of a machine as a data event. It's something you capture, you analyze, and use to make the very next cycle even better.
And right at the heart of this is something called AI native machining. Now, this is a huge shift. Think about it. We're moving away from machines that just blindly follow a set of instructions to machines that can actually feel what's happening. They sense vibration, temperature, load, and they make smart corrections on the fly. It's a game changer.
The other massive piece of this puzzle? The digital twin. And please forget what you think of as a simple 3D model. This is something else entirely. It's a living, breathing, virtual replica of the entire production process. It's basically a digital sandbox where you can test, tweak, and perfect every single step before you even touch a real piece of metal.
And this is where the magic of the digital twin really happens. It creates this powerful feedback loop. So you design the part, you simulate the process, you machine the physical thing, but then, and this is the key, the real-world data from that machine gets fed back into the simulation. What does that do? It makes the next simulation even more accurate. Every single cycle gets smarter and smarter.
Now, all these cool technologies, the AI, the digital twins, all the data, they're not just happening in isolation. They're all key parts of this bigger movement that you've probably heard of, Industry 4.0. And really, at its core, that's all about one thing, creating factories that are intelligent, connected, and can pretty much run themselves. But listen, having incredible tools is only half the battle, right? Especially in aerospace. You also need an unbelievably strict rulebook, a quality code that lays out the framework for making sure everything is safe. And that rulebook has a name, AS9100. If you want to make parts for aviation, space, or defense, this is not a suggestion. It's a requirement. It is the quality backbone that makes sure every single supplier, whether they're huge or a small shop, is speaking the exact same language when it comes to safety, reliability, and control.
So, you might be wondering, how's this different from something like ISO 9001, which is more common? Well, think of ISO 9001 as the foundation of a house. It's solid, it's good. But AS 9100 builds on top of that with layers and layers of aerospace-specific discipline. It forces you to think about risk at every single step. It adds super strict controls for product safety, especially for what they call key characteristics. Those are the features where even the tiniest little mistake could have a huge, huge impact.
And holding all of this together is one principle that is absolutely non-negotiable: traceability. Complete and total traceability. This means every single part, every batch of material, every process, it all has to be documented and tracked all the way back to the very beginning.
And why is that so important? Well, imagine a defect is found years later. With this system, you can instantly trace it back to its exact source, the machine, the operator, the material, and fix the problem so it never happens again. It's the absolute bedrock of accountability. It's how a super complex global supply chain can come together and build something like a jet engine with total and complete trust.
Okay, so we've got the digital tools and we've got the quality rulebook. Now let's get our hands dirty, so to speak.
let's look at two really specific, tough challenges. First, how to work with one of the gnarliest materials on the planet, and second, how you prove that the part you made is actually perfect.
All right, let's talk about titanium. You know this stuff. It's an aerospace super material. It's incredibly strong, super lightweight. What's not to love? Well, here's the problem. It is an absolute beast to machine. It fights you every single step of the way.
So what makes it such a nightmare? Okay, first off, it's terrible at conducting heat. So all the energy from cutting gets funneled right into the tip of the cutting tool, basically melting it. Second, it's super reactive chemically, so it literally tries to weld itself to the tool while you're cutting. And to top it all off, it work hardens. That means the very act of cutting it makes the surface harder, so the next cut is even tougher. It's just difficult.
But of course, engineers love a challenge. And to tame this beast, they've come up with a whole toolkit of really clever strategies. It's a mix of advanced material science and just plain smart machining.
And the solutions are just as specific as the problems. You use these specialized coatings on the cutting tools that act like a thermal barrier. You make the cutting edges incredibly sharp, with just the right angle to shear the material cleanly instead of rubbing against it. You blast the whole area with high-pressure coolant to get the kips out and keep things cool. And you use special techniques like climb milling to carefully manage the heat and the cutting forces.
Okay, so you did it. You wrestled with titanium and you won. You've got this incredibly complex part and it looks perfect, but how do you really know? How do you know what's going on deep inside the metal? How can you be 100% sure there isn't some tiny hidden flaw just waiting to cause a problem?
Well, this is where some amazing new inspection tech comes into play. A part might look absolutely flawless on the outside, but an advanced CT scan, and yeah, it's basically like a medical CT scan but for metal parts, on steroids, it gives you Superman's X-ray vision. It lets us see right through solid metal to spot those tiny, hidden flaws that you'd never see otherwise. It's how you guarantee the part is perfect, not just on the outside, but all the way through.
So, when you start to put all these pieces together, the digital smarts, the super strict processes, the advanced ways of checking your work, what you start to see is the arrival of the truly intelligent factory.
And that, right there, is the future of manufacturing. It's not about one single magic bullet. It's about how you seamlessly weave everything together. Machines that are aware of what they're doing. Digital twins that predict problems before they happen. A culture where you can trace everything. And the ability to prove perfection, right down to the microscopic level.
This whole revolution, it's letting us build the most complex, most reliable machines in human history. And it just leaves you with this one awesome question to think about. As our factories become just as intelligent as the amazing products they create, what impossible problems are we going to solve next? Thanks for watching Next Gen Manufacturing Nexus.